Hi everyone, this is P. Bharatij from Institute of Nodal Engineering. Today my subject is Basic Electronic Engineering. Topic: Node analysis on 4 nodes. Node. Node, a terminal of any branch of a network or an interconnection common to two or more branches of a network is called a node. If more than two elements meet at a node, then it is called principal node. Branch. A direct path joining two nodes of a network. The graph is called branch. A branch may have one or more elements connected in series. B equal to L plus N minus 1. L is number of loops plus N, that is number of nodes, minus 1, that is the equation of branch. KCL. KCL stands for Kirchhoff's current law, which is one of the fundamental laws used in electrical circuits analysis. The law states that sum of currents entering a node in a circuit must be equal to the sum of currents leaving the node. In other words, the total current flowing into a node must be equal to the total current flowing out of the node. This law is based on the principle of conservation of charge, which states that the charge cannot be created nor destroyed. It can be transmitted from one point to another. KCL is an important tool used in nodal analysis to determine the voltage and current relationships between the nodes of the circuit by applying KCL at each node in the circuit. Engineers and designers can determine the unknown currents and voltages in the circuit and analyze the behavior of the circuit under different conditions. KCL is also used in the circuit troubleshooting to identifying circuit problems such as shorts or open circuits and determine the necessary repairs. Overall, KCL is a essential law in electrical circuit analysis that keeps to ensure the proper functioning and designing of electrical circuits. Nodal analysis. Nodal analysis is a technique used in circuit analysis to determine the voltage at each node in a circuit. It is based on Kirchhoff's current law, which states that algebraic sum of currents entering a node is equal to the algebraic sum of currents leaving the node. To use nodal analysis, first identify all the nodes in the circuit, which are the points where the two or more circuit elements such as series resistors or voltage sources connect. We then choose one of the nodes to be the reference node and assign it a voltage of 0. We can choose any node to be the reference node, but it is usually convenient to choose the one connected to the ground or one with the most connections. Next, we write the nodal equations for the other nodes, which are the equations that relate the voltage at each node to the currents flowing into and out of that node. Especially, we write an equation for each non-reference node that states that the sum of the currents flowing into the node equals to the sum of the currents flowing out of the node. Once we have written the nodal equations of all non-reference nodes, we can solve them simultaneously to find the voltages at each node. This can be done using techniques such as matrix inversion or substitution. Procedure of nodal analysis. To identify the principal nodes and select one of them as the reference node will be treated as the ground. All the nodal voltages with respect to the ground from all principal nodes should be labeled except the reference node. The nodal equations at all the principal nodes except the reference node should have a nodal equation. The nodal equation is obtained from Kirchhoff's current law and then from Ohm's law. To obtain the nodal voltages, the nodal equations can be determined by before point. Hence, for a given electrical circuit, the current flowing through any element and the voltage across any element can be determined using the node voltages. Nodal analysis is a particularly useful for analyzing circuits with the many nodes or complicated topologies, as it allows us to write a relatively simple set of equations that can be solved to find the voltages at each node. However, it can become more complicated if there are dependent sources or non-linear components in the circuit. Features of nodal analysis. Nodal analysis is an application of Kirchhoff's current law. When there are n nodes in the given electrical circuit, there will be n-1 simultaneous equations to be solved. To obtain all the nodal voltages, n-1 should be solved. The number of non-difference nodes and the number of nodal equations obtained are equal. Types of nodes. Types of node in nodal analysis. Non-difference node, difference node. Non-difference node. It is a node which has a definite node voltages. Example, here node 1 and node 2 and all are the difference nodes. Difference node. It is a node which acts as reference point to all the other nodes. They are also called as datum node. Nodal analysis importance. Nodal analysis is an essential technique used in circuit analysis to determine the voltage and current relationships between the nodes of a circuit. It simplifies circuit analysis by breaking down a circuit into smaller manageable parts, enabling the design of the complex circuits, helping to identify circuit problems, and has applications in multiple fields. With nodal analysis, engineers and designers can optimize circuit performance, minimize distortion, ensure stable output voltage, and design the troubleshoot complex circuits. Nodal analysis is widely applicable in various electrical circuits, making it a versatile tool for engineers and designers in different fields. Nodal analysis example. Assume that we want to find the voltages V1, Vx in terms of R1, R2, R3, and we start by labeling the nodes circuit. Let's call the node the top corner of node 1 as node 1 and the node in between R2 and R3 is node 2 and the bottom node is node 3. Next, we write down the nodal equations for each of the nodes. The nodal equation for each node is sum of the currents flowing into this node equal to sum of the currents flowing out of the node. For node 1, we have 5 minus Vx by R1 equal to Vx minus 0 by R2 plus Vx minus 0 by R3. Simplifying the equations by cross multiplying and rearranging, we get 5R2 R3 minus Vx into R2 plus R3 equal to R1 R2 Vx plus R1 R3 Vx. Vx equal to 5R2 R3 into divided by R1 into R2 plus R1 into R3 plus R2 into R3. Therefore, the voltage Vx in terms of R1 R2 R3 and V is Vx equal to R1 R2 R3 by R1 R2 plus R2 R3 plus R2 R3 R1. And that's how we solve the circuit using nodal analysis. Nodal analysis with 4 nodes. We want to find the voltage at node 1, node n1, n2, and n3, and n4. n1, n2, n3, and n4. To solve the problem using nodal analysis, which we follow these steps. Choose one of the usual nodes to be the reference node. Usually chosen as the node with most connections or the one connected to the ground. In this case, we choose the node at the bottom of the circuit as reference node, that is ground. Write down the nodal equations for each of the other nodes. Nodal equations for a node is sum of the currents flowing into the node equal to sum of the currents flowing out of the node. For example, nodal equation for n1 is V underscore n1 minus V n2 by R2, V n1 minus V n3 by R3, V n1 minus 10 by R1 equal to 0. Equations for nodes n2, n3, and n4 can be written similarly. Solve the resulting system of equations to find the voltages at each node. For this problem, the nodal voltages are Vn1 minus Vn2 by R2 plus Vn1 minus Vn3 by R3 plus Vn1 minus 10 by R1 equal to 0. Vn2 minus Vn1 by R2 plus Vn2 minus Vn4 by R4 equal to 0. Vn3 minus Vn1 by R3 plus Vn3 minus Vn4 by R5 equal to 0. Vn4 minus Vn2 by R4 plus Vn4 minus Vn3 by R5 equal to 0. These are the nodal equations. We can simplify this system of equations by multiplying equation by the product of resistance in the denominator the equation. This gives us Vn1 minus Vn2 into R3 into R4 plus Vn1 minus Vn3 into R2 into R4 plus Vn1 minus 10 into R2 into R3 equal to 0, and Vn2 minus Vn1 into R3 into R4 plus Vn2 minus Vn4 into R2 into R4 equal to 0. Vn3 minus Vn1 into R4 into Vr5 plus Vn3 minus Vn4 into R2 into R5 equal to 0. Vn4 minus Vn2 into R3 into R5 plus Vn4 minus Vn3 into R3 into R4 equal to 0. We can solve the system of equations using the method we choose, that is example substitution or matrix inversion, to find the voltages at each node. Example 1. The number of nodes that are present in the given circuit is 3. The nodes that are present in the circuit are numbered as shown in the figure: N1, N2 and N3. N3 is grounded, N1 and N2. Let N2 be the reference node and the node voltages will be 0. By using Kirchhoff's current law at each node we get V1 by 30 plus V1 minus 100 by 5 plus V1 minus V3 by 10 equal to 0. Let it be equation 1. This is the result of KCL at the node 1. V3 minus V1 by 10 plus V3 by 10 plus V3 by 20 equal to 0. This is equation 2. This is the result for KCL at node 3. 1 by 30 plus 1 by 5 plus 1 by 10 into V1 minus 1 by 10 into V3 equal to 100 by 5 minus 1 by 10 into V1 plus 1 by 10 plus 1 by 10 plus 1 by 20 into V3 equal to 0. For solving the above equations, we get V1 equal to 68.2 volts, V3 equal to 27.3 volts. Applications of 4-node nodal analysis. 4-node nodal analysis is a specific application of nodal analysis that is commonly used in different analysis and design of various electronic circuits. 4-node nodal analysis is a powerful and flexible technique that can be used to analyze many different types of circuits, making it an essential tool for electronic circuit designers and engineers. Some of the applications of 4-node nodal analysis include analysis of bridge circuits used for measuring resistance, capacitance and inductance. Analysis of amplifier circuits used for amplifying signals. Analysis of filter circuits used for passing or rejection certain frequencies of an input signal. Analysis of an oscillator circuits used for generating continuous waveforms. Analysis for power supply circuits used for providing DC voltage to the electronic circuits. Importance of 4-node nodal analysis. 4-node nodal analysis is a key technique used in the analysis and design of electronic circuits. Its importance lies in the ability to provide accurate results, its flexibility in analyzing complex circuits, and its usefulness in optimizing circuit designs. 4-node nodal analysis is also an important concept in electrical engineering education, providing students with practical skills and deeper understanding of circuit theory. Conclusion for 4-node nodal analysis. In conclusion, 4-node nodal analysis is fundamental technique in the analysis and design of electronic circuits based on Kirchhoff's current law and allows for the accurate results, flexibility and optimization in the analysis of complex circuits. 4-node nodal analysis is an essential tool for circuit designers and engineers, providing practical skills and deeper understanding of circuit theory. Thank you.